one place, and there's no plumbing. The butcher, he has a ghost thing, so it's just sheet over him, but it had like the mesh aisle, so you can see out. It's like, save the go to the next house. So there's this group of people walking by us. He puts it on and goes, I'm done. You don't like it? I guess not.
Dude, I'm done. That's great. Yeah, I thought I had Jack down and I'm like, hey, there's pizza bus around here. He comes running. Pizza bus into the driveway. Sure, he went and yelled at him. Is there a pressure road?
Where's the pen?
Candy.
Whoa. That's
Because nobody in our circle has a Wi-Fi. It's always the only one, so nobody comes in there.
They don't have the pen.
no pen. No class.
Well, because we had all that extra stuff. Taylor starts going around and goes, hey kids, I got free brownies and cookies. I was like, Taylor, go to their parents. Ask their parents. He goes, the cops call you. I'm sorry, Sarah.
It's always better if it's a female. I don't know why. It's more socially acceptable for a woman to be like, you're cute. It's a human.
Yeah.
About sense of society.
You're gonna hurt yourself.
You had a homework due today, right?
Friday morning.
Friday?
You can have one.
You can have it if you want. I have it.
Jesus, you have relaxed.
I did mine Monday, so I didn't have any more homework.
You want it?
No.
We both left Friday because I didn't. I'm mad at Sydney. There was more due yesterday in transportation, and I had 3 to 5 early. She's like, hey, it's not due yesterday, so I didn't check this. Anyways, I was like, turn this to a good time. She's like, Terry, it was due today. So I did change it.
Okay. Thank you.
Just want you to take it if it's working.
Okay, so good morning, everyone. So just, as a summary of the design and the analysis for shear. Okay. Let's say for design. Okay. So for design, what's the problem statement? What would you have in a design problem? What are the given things and what are the required things? So for design, what do you think? What are the given things? FC prime, FU, okay? Those are given, okay? And the dimensions, B and D, okay? So the dimensions would be given. When you design for the shear, okay? You have the dimensions, you assume the beam dimensions, maybe for bending, you start designing for bending, or you just assume them, okay? You say, okay, those are the B and D that I'm gonna use as we saw in the guidelines in chapter 4, right? According to the beam span, so the depth of the beam or the height of the beam is the span divided by 10, and then the width is half that value, okay? So you have the dimensions, okay? So, and what are you required to find? For a design for shear, what are you required to find? Mm.
The area of the shear steel, the spacing, how big?
Yeah. So design the stirrups. What do I mean by designing the stirrups? Two things. A V stands for shear, the area for the shear, the area of those stirrups. And S. So that's the area of the stirrups. And S is the spacing. And definitely in the givens here I missed something. What's that? The most important thing. What's
Areas, the actual area steel?
no? You need the area steel if you're going to use the conservative, the less conservative equation for the design for calculating VC. But if you're not going to use that equation, you don't need the area steel. What's given here? The ultimate. You're designing it for shear, right? You're designing the section to resist a given shear force. How much is that given shear force that you should design your beam to resist? Okay? So if you have all those given, and you just need to find A, V, and S. Okay? Unfortunately, you just have one equation for design. You cannot find both parameters, A, V, and S, just from the design equation. You have to assume one of them and find the other one. Okay? To be satisfactory to resist the shear force. So what are the steps? The first step is find phi VC. Phi is 0.75, VC is 2 lambda square root FC prime B web D. Okay? So you find the strength of the concrete. Once you find the strength of the concrete, you have two options now. Okay? If phi VC, okay, is larger than V ultimate, or V ultimate is less than phi VC divided by 2, so no stirrups are required. Okay? That's the first option. The second option is if phi VC, okay, or V ultimate, okay, is larger than phi VC. Sorry, this is divided by 2 here, okay? Phi VC divided by 2, okay? If phi VC divided by 2 is larger than V ultimate, then you don't need stirrups. If V ultimate is larger than phi VC divided by 2, but it's less than phi VC, then actually you don't need stirrups, but the ACI code requires that you provide the minimum amount of stirrups. So here, provide the minimum amount of stirrups. How much is the minimum amount of stirrups? You have A, V, and S, okay? So S max is equal to AV, whatever AV you're going to assume, okay, multiplied by F yield divided by 0.75 square root FC prime B web. And the other equation is AV F yield divided by 50 B web. Those equations are in the ACI code. Okay, you don't have to memorize them. Those are in section 9.633. Okay? So you have two values here. Which one you're going to use? The smaller value or the larger value?
The larger larger value?
No, the smaller value. Why? Because, no, you have two values. One of them is small spacing, and one is large spacing. Providing small spacing, that's the larger amount of steel, right? Smaller spacing means that you're providing more steel. So you actually have to provide the more steel from those equations, okay? Not the less steel, okay? So actually you're going to take the smaller spacing. When the spacing gets less, it means that you're providing more steel, right?
Yeah, but you said you want to provide minimum amount of steel.
Yes, those two equations provide the minimum amount of steel. You pick the smaller spacing out of those two values, that's the minimum amount of steel. You remember even like for the longitudinal steel, we had two equations, right? For the longitudinal steel, the minimum amount of steel, you have to satisfy those both equations. So you get the larger value of those, right? So here the same, you have to satisfy both equations for the maximum spacing. Okay? You have to satisfy both of them. So let's say this is 4 inches and this is 3 inches. Okay? So should I use 4 or 3? Which one satisfies both equations? The 3 inches satisfies both equations, not the 4 inches. If I provide 4 inches, then I'm providing, the maximum spacing is 3, not 4. The maximum is 3. Okay, I cannot exceed 3. Is it clear now? If you have two equations that give you the longitudinal, the minimum amount for longitudinal steel, one gives you 3 inches square and one gives you 4 inches square, which one would you use? The 4, right? The maximum, the more steel, because the 4 inches square is larger, so it satisfies both equations. Here, the minimum spacing is the one, or the less spacing is the one that's going to satisfy both equations. Okay? So that's if VVC divided or V ultimate is in between those values. If V ultimate is less than VVC, then actually you don't need steers, but we need to provide the minimum amount of steers. Okay?
Is that divided by 50 V1 on the
Yeah.
board?
And then the third case here. If V ultimate is larger than VC, then stirrups are needed, okay? And you need to design for those stirrups. Here, you don't need to design for it. Just use AV, minimum AV, okay? Just 2 branch, for example, number 3, okay? The stirrups cannot be less than number 3. So 2 branches, number 3, and find S max. That's it, okay? But if stirrups are needed, so I need to design for those stirrups, okay? So how much is the shear force resisted by the stirrups? I need to find VS, okay? What's VS? VS is V ultimate minus VVC divided by phi. Where did this equation come from? This is simply that V ultimate is equal to VVC plus VVS. The shear force is resisted by the concrete and the steel. So VVS, you're just going to subtract this from V ultimate and then divide by phi. You're going to get how much shear force should be provided by the stirrups. So now, once you know this value, okay, you can find S. Find the required spacing. How much is the required spacing? S is equal to, okay, AV F yield D divided by VS. Okay? And that, has to be less than S maximum, those values here. Okay? Can it be larger than S maximum? If it's larger, then it's not acceptable. You have to use those maximum spacings. Okay? Does that conclude the requirements? No. Still, once you calculate VS, okay? So if Vs, okay, is less than 4 square root Fc prime B web D, here I have equation 1. Let's say this is equation 1, this is equation 2 here, okay? If Vs is less than this, then S max is limited to the least of equations 1 to 4. I have here equation 1 and 2, okay? What's equation 3? S max is D divided by 2, that's equation 3, and S max is limited to 24 inches. That's equation 4. Okay? So once you find this S, it has to be less than S maximum. How much is S maximum? You have to calculate 1, 2, 3, 4 values. And it's the least of those 4 values if Vs is less than this value. Okay? What if Vs was larger than that value, but less than 8 square root Fc prime B web D? So S max is limited to the least of equations 1, 2, 5, and 6. So those two equations remains the same, but those two values here is halved. D divided by 4 instead of D divided by 2, and 12 inches instead of the 24 inches. By the way, all those numbers are in the ACI code, okay? I'm just summarizing them for you here, okay? Okay, what if Vs was larger than 8 square root Fc prime B web D? That's the last thing that you have here. What if Vs is larger than this value? You need to change the dimensions. B web and D, so that Vs is less than 8 square root Fc prime B web D. Vs cannot be larger than 8 square root Fc prime B web D. Okay? So that's the summary. That's all the equations that you need for a design of a beam. Okay? Everything. This paper, this just one single paper, has all the equations, all the design here. Okay? You don't need anything more than those steps. Okay? They have all the equations. Any question here? Okay. Now, let's solve some examples. We're going to actually start with an analysis, okay? Not a design. Sorry. Not an analysis. That's the analysis is the second. We don't have analysis here. This is the first example here, okay? We have a section with V ultimate equal to 38K. Beam section with the shear applied on it that is equal to 38K. Fc prime of the concrete, compressive strength of the concrete of that section is 4 KSI, And we're required to find the minimum cross section dimensions. So this problem statement is different than what we summarized, okay? Here you're required to find the cross section, okay? So that no stirrups are required. How can we solve this problem? What do you think? It doesn't have the same problem statement as what we summarized here. But again, this one page, okay, summary for the design, it has everything. What do we need to do here? What's the problem statement? It says find the dimensions, okay, so that no stirrups are required.
So we need to find.
So when you see here, when you look here, you have those three cases. Where is the case where no stirrups are required?
First one.
This one. So you need the phi VC divided by 2 should be larger than the other. If you can satisfy this, then you don't need shear reinforcement. Okay? So that's what we're going to do. Okay? So let's calculate phi VC. Phi is 0.75. VC is 2 lambda square root FC prime B web D. This is normal weight concrete, so lambda is equal to 1. So 0.75 times 2 times 1 times square root FC prime. How much is FC prime? It's 4 KSI, so it's 4,000 PSI. It has to be in PSI, okay? Multiplied by B web D. How much is B web and D? How much is B and D? That's what you need to find, okay? So phi VC is 94.87 B web D. No stirrups are required if phi VC divided by 2 is larger than or equal V ultimate. So therefore, I'll just put this strength divided by 2, I will equate it with V ultimate. Okay? Equate that with V ultimate. How much is V ultimate? How much? 38? 38 what? 38 kips. So it's 38,000 pounds. Okay? So the units here are in inch and pound. Okay? So from this, you can find that B web multiplied by D has to be equal to 801.1 inches squared. Those are the required dimensions so that no stirrups are required. So just choose any B web and D so that it satisfies this value. So what we use here, you want actually that B web is almost 1/2 the depth of the section, okay, the height of the section, not the depth. So what we use here, use a 24 inches by 36 inch beam. This is what the book chose. I think there might be a better choice, okay, smaller B and larger D, but anyway, this one satisfies the equation. So for those values, B web multiplied by D, multiplying those two values, D here, this is H, this is B web, and this is H, so D is H minus D prime, so D is 33.5 inches. So B web D is 24 times 33.5, so it's 804 inches squared. It's larger than this value, then that's the dimensions, okay? This is the minimum dimensions, okay? So that this section, you can have that section without providing any stirrups, okay?
Is D prime always 2.5?
D prime do 2.5, yes.
It's always 2.5.
If you have the steel on one layer, then it's 2.5. If you have the steel on two layers, one layer, then 2.5. If it's on two layers, then it's 3.5. You don't know here, so you just assume one layer. Okay? So here, that was a design problem, but you weren't given the dimensions. You were required to find the dimensions so that no shear reinforcement was required. Okay? Yes?
Does it matter whether D prime is 3 or 2.5?
No, if you say 3, that's fine. Yeah. Okay? Any question? Okay. Another example. Let's solve another example here. We have a beam with those dimensions. We have 14 inches. It's 14 inches wide. And the total height of the beam is 27 inches. You have the longitudinal steel somewhere here with a cover of 3 inches, so D is 24 inches. So that's D. D prime is 3 inches, H is 27 inches. For this problem, we're given F yield for the stirrups is 60 KSI, and FC prime is 3 KSI, 3000 PSI, okay? Where we are use number 3 U-shaped stirrups. So I know what type of stirrups I'm using. I know it's number 3 and it looks like a U-shaped, okay? But I'm required to find the spacing, okay? Find the required spacing for the following cases. The first one, if V ultimate is 12,000 pounds. The second case, if V ultimate is 40,000 pounds. The third case, if V ultimate is 60,000 pounds. And the fourth case is 150,000 pounds. Okay? So, how to solve this problem? Did you take a copy of the summary that we wrote? Just let me know what are the steps. Find phi VC, okay? So the first step is finding phi VC. The first case here is V ultimate is equal to 12,000 pounds, okay? The first step is finding phi VC. Phi is 0.75. VC is 2 lambda square root FC prime B web D. So everything we need here is known. 2 times lambda. As long as it's normal weight concrete, then lambda is 1. If I say it's lightweight concrete, then it's 0.75. Okay? Multiplied by square root FC prime in PSI. Multiplied by B web. How much is B web? The width, 14 inches. D, the depth is 24 inches. So phi VC is going to be 27,605 pounds. 27,605 pounds. What's the next step? You have, to check which one of the three cases is it, okay? So phi VC divided by 2 is how much? 27,605 divided by 2, which is 13,803 almost, okay? Okay, according to the summary, which case are you in? Okay, so V ultimate is less than phi VC divided by 2. So the concrete is enough, okay? This V ultimate, which is 12,000, is less than this value. So therefore, no stirrups required. You don't need any stirrups here for that case. If the shear force is 12,000 pounds and you have that section, you're good. You don't need to provide any stirrups. Let's see the second case. For the second case, V ultimate is 40,000 pounds. Which case are we in? So as you see here, V ultimate is larger than, V ultimate is equal to 40,000. That's larger than phi VC. Phi VC is the 27, right? 27,605. What does this mean? Is it the second case or the third case? Third case. So what does this mean? You need to find Vs. How much is the shear force that should be resisted by the stirrups? Okay? So how much is Vs? According to the summary. V ultimate minus phi VC divided by phi. V ultimate is 40,000 pounds minus phi VC, which is 27,605 pounds divided by phi, which is 0.75. So Vs, you need to provide stirrups that would give you strength of at least 16,527 pounds. This should be the strength of your stirrups, the nominal strength of the stirrups. To get this strength, how much spacing of those U-shaped, number 3 U-shaped stirrups would give you this strength? How much is S? AV, F yield, D divided by Vs. Okay? So how much is AV, the area of the stirrups? Do you have that given? It's the stirrups are number 3, so you need to find the area of a number 3 bar. And you have 2 branches. When you have a U-shaped stirrups, both branches are resisting the shear, okay? So 2 times the area of a number 3 bar, okay? So an area of a number 3 bar is 0.11 inches squared. I just multiply by 2 because I have 2 branches, okay, in a U-shaped stirrups. Multiplied by F yield. F yield is 60,000 psi. Multiplied by D, the depth is 24 inches, divided by Vs, which is 16,527 pounds. So S is 19.17 inches. You need a spacing of 19 inches, okay? To resist, to be able to resist, okay, the shear force, okay, for those stirrups. Does that conclude our design? Check it. Check it against what? S max. You have 4 equations. What 4 equation will you use? How can you determine which 4 equations you will use?
less than 4 squared f c prime b over 2.
Okay, let's go to the summary here again, just as a reminder. So I need to check S max. I have two cases, if Vs is less than this value or if it's larger than this value but still less than this value, okay? In any two cases, in any of those two cases, I still have to use those two equations. The difference between the two cases is either using those or those, okay? So let's find those first two equations first, okay? Equation 1 and equation 2, okay? So S max from equations 1 and 2. Definitely they are not named equation 1 and 2. I just named those in the summary, okay? But you have their number in the ACI code, okay? In the ACI 380. So S max, okay? The first equation says that S max is AV F field divided by 0.75 square root FC prime B web. So AV is 2 times 0.11 inches squared. F yield is 60,000 psi divided by 0.75 square root FC prime, which is 3,000 psi. B web is 14 inches. So this one is 22.95 inches. The second value is AV F yield divided by 50 B web, which is equal to 2 times 0.11 inches squared. F yield is 60,000 psi divided by 50 B web, which is 14 inches. So that is equal to 18.86 inches. Yes?
Scroll just a second.
Where?
Right, too far.
More?
No, just S down. Just go behind.
Hmm?
Here.
Okay. So those what comes from equation 1 and 2. Now, should I use equation 3 and 4 or equation 5 and 6? That depends. I need to compare my Vs, okay? I need to compare Vs, which is, how much was Vs? 16,527 pounds, with 4 square root FC prime B web D. So let's see, 4 times square root FC prime B web D. That's equal to 73.614 pounds. Is Vs less than 4 square root FC prime B web D or larger than?
I
Hmm?
got 73,013. 73,000. That's 73.64 kids.
73,000. Okay. Okay. So that's 73,000. Okay. So Vs is what? Less or larger than? It's less than that value. What does this mean? Equation, no. Equation 3 and 4. Right? What does equation? So therefore, S maximum is limited to what? What's equation 3? D over 2. How much is D? 24 inches divided by 2. So 12 inches. What's the second equation? 24 inches. So now, for S, for the spacing, I actually got 5 values. What is actually required is 19.17. but we said the maximum value cannot exceed any of those values. So how much would you use? 12. Use the least spacing. So that's the answer here. The spacing that will be provided is 12 inches. Okay? That's the spacing that you need. You actually needed 19, but the ACI code says there is a maximum spacing that you cannot exceed, which is 12 inches, so you cannot have any spacing that is larger than 12 inches for that case. Okay? Any question? Okay. So that's the spacing here. Let's see the third case, or the third part of the problem. How much was the shear force that is required to be resisted? 60,000 pounds. Right? So definitely you need a VS, right? It's not case 1 or case 2, it's definitely case 3, right? The ultimate is larger than VVC, right? We already know VVC was 27, okay? So let's calculate VS. VS is V ultimate minus VVC divided by phi. V ultimate is 60,000 pounds minus VVC, which is 27,605 pounds. VVC depends on the dimensions. The dimensions didn't change from one part to another in this problem. So VS, the stirrups, should provide a strength of 43,193 pounds. That's the shear force that should be provided by the stirrups. What should I use this for? Finding the spacing. The spacing is AV F yield D divided by VS. AV is 2 times 0.11 inches squared. I'm just repeating the same steps as we did in the previous section or the part. This is 60,000 psi multiplied by D, which is 24 inches, divided by VS, which is 43,193 pounds. So the required spacing is 7.33 inches. What do you have to check this against? Equations 1 and 2 remains the same, right? Equations 1 and 2, we already calculated equations 1 and 2, they were 22.59 and 18.86. Should I use equation 3 and 4 like here, or equation 5 and 6? That depends on comparing VS, okay, with 4. So comparing VS is 43,193 pounds, and comparing this with 4 square root FC prime B web D, how much was that? We already calculated that before. 73,000 and what? 614. So it's still less than that. So all the 4 previous values still, in part B of the problem still, are correct here. So how much is S then? No. 7.33. You need 7.33. The maximum value is 12, but you need 7.33. Okay? So actually this one is the least value now. Okay? When you provide the least spacing, it means that you're providing more steel. You need to provide the more steel, okay, out of all those values, okay? Any question?
So in the previous one, when we had it to be 12 inches, and when we first test with the number 3 U stirrups, does that mean those won't work? Since the spacing was 22.95?
No, I don't understand. You have those 4 values, right?
You just,
1, 2, 3, 4. Okay? You just pick the smallest out of those. So the smallest is 12 inches. You're not going to use this at all. Okay? You would actually use one of those 2 values if you're in case 2, where V ultimate is less than PVC but larger than PVC divided by 2. Okay? So now that's, so the equations here, equations 4, 3, and 4 still apply. Let's go to the 4th case. V ultimate is 150 pounds, 150,000 pounds. So Vs is V ultimate minus VVC divided by phi. So V ultimate is 150,000 pounds minus VVC, which is 27,605 pounds, divided by phi, which is 0.75. So that is equal to 163 and 193 pounds. Okay? How come? No, there is something wrong here. 150 VS.
I'll check it twice.
Oh, okay, that's 73. Yeah, okay. So now we need to calculate. So this is VS, okay? VS is 163 and 193 pounds. Comparing this to 8 square root FC prime B web D. How much is this value?
247.
How much? 147? 228 pounds. Okay? So VS is larger than this. What does this mean? Okay, so this section is not valid. You cannot design this section. You cannot find the stirrups for that given dimensions. You have to change the dimensions. Okay? So we're not going to do this here, okay? But you can, if you're designing a beam, just change the dimensions and repeat the steps. Any question here? Okay. So see you on Friday.
Just a guessing game at that point? Or
Hmm?
is it just a guessing game at that point?
Okay, so let's see here.
Sorry, guys.
What I would do is I need this value, okay, 8 square root FC prime B web D, to be equal to VS, which is 163, okay? So just, find B and D so that they are equal to 163, okay? As we did in the first question. You remember the first question?
I won't be here on Friday because I'm going for a rugby game to Chicago. So,
Can you bring it tomorrow?
Yeah. I was going to tell you if I'll bring it.
Okay.
Oh, our next test, is it going to be over 4, 5, and 6, or is it going to include 8?
8? No, no.
Or just 4, 5, and 6?
4, 5, and 6.
Oh, okay, cool. God bless.
And that's our somewhere around the same
It's
time.
the syllabus. It's on Thursday.
This Thursday?
No.
Oh.
It's Thursday. I'm not going to be.
Okay, yeah.
So I guess it's Thursday. So I'll just discuss with you if you want on
Yeah.
Tuesday or Thursday, whatever you.
Can we push it a week back?
No, because I don't want to lose election. I won't be there. During that.
I got
week.
you.
So.
Okay. I'm gonna push for Tuesday because we have 2 tests on Thursday already.
Okay.
So. Or no, that's our own class. All right, we have 2 tests on Wednesday.
Oh, okay.
Sorry about that. Thank you very much. Have a good day.
Next Thursday?
It's on the 14th. I mean 15th. That's it, like the rugby field. I bet you they closed that door. Did you hear that? The email?
Yeah.
That security door ain't be open for 2 more minutes.
Yeah, our final report's due 15, our next progress report is due on the 5th.
Shit. Good price for it down the bill. Good price for it down the bill.
Yeah, our second.
It's the second. I thought we were that was the first one.
We have 2 progress
I
reports.
know.
That's like one I'm sure is one more.
It is. Everything goes up pretty quick. Except my green. Progress report due on the 5th, what is that? Monday? Next week? Monday? Monday. Next Monday?
Wow. Thanks for fucking us. What else do we need to do? So that makes them finish the profiles are 230 feet across. Yeah, and I told him like we only need maybe 150 max because I thought I was like our max on the road that we want to do. So we should go back and read it.
No, but he has profiles of the ground that it is. Can you see the defined road profile? Like,
I haven't seen them since
I know,
like last week.
say that profile comes from this way, and also from this way. At some point, you should see it